Now, hi everybody. We're getting recorded now, and this is what we're going to be talking about today. Today is the domain and range of a function. Do me a favor. If you've ever heard of domain and range or done anything with it in Algebra 1 or before that, I mean, it's possible you would have seen it before that too. Can you please type that in the chat? Say, I've seen it or I have not seen it. It would be helpful to sort of know what I have to deal with at the beginning here. So if you have seen this before with domain and range, type it up in there. Reem has not. One person has voted. Guys, this is, with tomorrow being voting day, more people should vote. Okay, we have one yes and one no. Give me one more and then I'll move on. Thanks, Gage. I appreciate you putting me right in the middle. Okay, so here's what we're gonna do, guys. We're talking about domain and range. It's pretty easy, but for some reason, this is something that like trips people up. I don't really understand why, okay? Because when we're talking about this is, at the end of the day, this is all it is. When we say the domain, it just means anytime we're looking at a function, that's all of our x values. So like when we look at this, our domain is every x value we can have. So domain is x, okay? And our range, that's all of our y values. So they're the y's. That's it. Now, this is the thing. We can look at this graphically. We can look at this in lists. We can look at this as equations. But really what we're generally talking about when we look at domain and range is, you know, what does it look like if we were to list it all out to see what are my inputs and what do they look like? What are my outputs and what do they look like? And sometimes they give us good information and help us out in terms of recognizing the patterns that develop when we're looking at a function. Now, legitimately, as long as you understand x's domain and range is y, then you should be in pretty decent shape at the beginning of this. What I want to try to do is give you some of the ways that this could look and sort of show us how this would work. And then we're going to have a homework assignment that's kind of like fill in the slide sorts of things. But most of it's going to be look at this and tell me what the domain is. Look at this and tell me what the range is. So let's go with this first. We talk about roster form. All a roster is, this is just a list, okay? We're talking about a list for something like this. Now, when we do it though, the part about this that's important is that when we're making a list, we're gonna be doing what we call set notation. And I'm gonna put this in words here. I'll say set notation. And what it means is that when you're doing this, you just have to make sure that you put these little brackets around the outside of whatever this is going to be, okay? So if I'm talking about a roster form of a domain, so let's say this is my domain. So we're talking about all of our x's, and we're about to do a list of numbers, okay? So what you do is you make a little bracket like that. Now, guys, please understand, this is not an art class. I don't care how good this looks. It's basically just like a squiggle. Now, for me, it's like you make an S and then you mirror it this way and you're good. We're talking about the domain. This is listing your x's in such a way of saying, okay, we got a -2, we have a 7, we have a 5, we have a 13, and we have a 23. And then we close that set and we're done. That's how we list it. Our roster form is basically you put commas between the numbers, you list them. If anything repeats, you don't write it twice. You just list all the things you have there. They could be from smallest to largest. I didn't put these in order. I put the 5 and the 7 in a different place. It's fine. The roster form is just make a list, okay? If we talk about a table form, generally we're talking about the whole function, okay? And so normally what we're going to be doing is we're going to be making something that's going to look like this, where we'll have an x, we'll have a y, we'll make a table on this side, and we can have it look like this, where my x's will be, let's say I have -2, 7, 5, 13, and 23, like I have from this one. So that's my domain. And I could have my y values be 15, 27, 13, 65, and -8. Where do those numbers come from? My head. I just listed them. But when we talk about this, when we say roster form or table form, the general idea is how do we put this together in such a way that we can list all of them? And so here, our domain is all of our x values here. Our range is all of our y values here. And that's kind of the way that we would look at it. Here we listed our x's. Here we listed both. We could make a table of just our x values, but it would kind of look like the roster. And so there's really no reason to do a table unless you're using your x's and your y's. So here's my question. Is any of this crazy, or does this seem like it would be a relatively easy thing to do? So this is where you type it in the chat. You could say easy or I don't get it. Just the roster and the table. I'm not even talking about anything else. Somebody's got to type something though. I think I get it is kind of okay. Easy is good. That looks a little annoying. You are correct. Some of this stuff is annoying. It's a lot more useful when we start to look at the graphs themselves. So when we talk about roster and table, the whole point of this conversation is to say, look, it's easy. And then when we move it to the graphs, you'll say, oh, I kind of see what we're doing here. Okay. Now, as a quick example, what we're going to be doing is we're going to be kind of rolling through here and making a domain and range of a general list. So here, let's say the function is our inputs are the months of the year and the outputs are the number of days of the month, okay? So let's just write this. So our domain is our input. So what we will put over here, our domain is the months and the range is the number of days in the month. Now, we assume the function is restricted to non-leap years. All right, that's fine. Okay, so here's my question. Y'all, how many elements or how many numbers or how many pieces am I going to have in my domain? If this is the list of the months, how many will I actually have? Oh, somebody should type a number in here. How many months are there in a year, y'all? Yeah, there's 12. So right now, if they're asking you to list a domain like this, the idea is you've got to list all of the things that you have here. Now, I'm going to do this mostly because it's a relatively easy example for us to go through. But if I'm going to do that, I'm going to kind of make them a little bit shorter. So we've got January, February, March, April, May, June, July, August, September, October, November, and December. Okay, there we go. And I close that set. Now you notice the beginning of the set's there and I had to close it here. Full set of the domain is there. All of our inputs are there. Now we're talking about the days in each month. Now, y'all, this may be something that you don't remember super well, and it's fine if you don't. If you don't remember which ones they have, let's just do this for a minute. Right now, if you don't remember how many days January has versus February versus March, why don't we do this? What are the possible options that we have for days in a month so that we can have our range values here? What is one of the possibilities we have for the number of days in a month? 31, absolutely correct. 31 days in a month.
Or 30.
Or 30, that would also be possible. What else? 29 would be this year because it's a leap year, but if it wasn't a leap year, how many are there in the month of, let's say, specifically February? Yeah, 28. So right now, are there any other outputs that we have in a non-leap year for a possible range value? We look at that. Is there anything else we're going to have, or is that it? This is where you're questioning yourself, thinking, wait, is there another? No, man, this is it. We have 30, 31, or 28, and that is solid it, what we could possibly have, okay? These are our only outputs. Now, there's a lot of ways we could go through and try to remember it, but I'm going to tell you this. I'm never going to test you on, can you tell me specifically how many days there are in June versus December? How many days there are in August versus March? I don't care. Right now, all I wanted you to know is that there's a possibility that when you have a domain that has a lot of elements in it, like in this case, 12, that are all separate and unique, your range could have less because you are looking at values that could be paired more than once with our domain. Because remember, a function is a function if every input has exactly one output. It's okay for the output values to repeat and it still be a function. What you shouldn't have is something where you have more range values than you have domain values. Because if that's the case, that means that one of these guys would repeat, which we're not allowed to do, okay? So when we're looking at this, this is where we're at. Now, if I did this in table form, this would let you know which goes with which. And that would be fine, but it's not really something I'm as interested in right now as I am just recognizing that they don't always have to have the same number of elements when we're doing this, okay? And when I say element, it means something in there, because as you can see, we're not always talking about numbers when we're looking at things inside a domain versus a range, okay? Now, that being said, that gives us the general idea of how we would use a roster form. I'm going to flip the page here for a second and take a look at a table form. And that's, see, it's a table because it's a table that it's on. Ha ha! First dad joke of the day, guys. That's the best. You guys got to hear my dad joke, and it got recorded, which means it's going to be here for all time, even though literally nobody watches my videos, even the ones that I dress up for. All right, now, that being said, let's take a look here for exercise 2. The other thing that we can use to define a domain and a range is an actual equation for our function. So they're giving us the domain of this set, 1, 3, and 5, and they want to have us do the range. Now, I do want to show you this because this is something that's kind of important to figure out. When they've given you an actual rule for our function, what they're asking you to do is to say, if my domain is this, then let's write that in here for our set itself. So our domain is 1, 3, and 5. To find the range values that are paired with it, I need to do some work off on the side here and plug those numbers in. So for this first one, it's going to be 2 times that 1 plus 1. And for all of them, we're doing the same work. It's just we're plugging in different domain values to figure out what we're going to do. This is 2 times 1 plus 1, 2 times 3 plus 1, and 2 times 5 plus 1. Because what we're going to find is what are our outputs or our range values that go along with this. 2 times 1 is 2, plus 1 is equal to 3. So my range value is 3. 2 times 3 is 6, plus 1 is 7. So that's 7 here. 2 times 5 is 10, plus 1 is 11. So it's 11 there. So right now, this is a table format to show the whole function. We've got 1 with 3, 3 with 7, and 5 with 11. And we showed our work over here on the other side. Now, this is a little bit more difficult to put them together in that you have to do some work. But does this seem confusing? And if so, now would be a great time to ask a question if you're not sure. So we're about to move to the realm of, hey, let's look at some graphs. And I don't want you to be confused when we talk about this.
Where did the multiplication come in?
If you look right there, the function, the f function right there is 2 times n plus 1. So the n is our input value, which means our x. So that variable is our domain variable. So what I did is I came down here, 2 parentheses plus 1 came from that rule right there. And so what we did then is, since we're replacing that n with whatever our domain value is,
I see. Okay.
I just put parentheses and plug those in. Does that make sense?
That's fun.
Okay, cool. That's what I figured. I just wanted to make sure. Now, when we're talking about the graph, that's the place where we have to do a little bit more work. Now, if you were in Algebra 1 at Urbana High School, you would have seen this, but it was like, we normally do this like September of Algebra 1, and then we don't talk about it ever again. So like this could very well have been 2 years and 2 months ago for you. And it's fine if that's the case. I just want to make sure that you understand, if you don't remember this, it's all good. But if you did have Algebra 1 here, you would have seen it. So here's what we do. When we talk about the domain of a graph, I call this the walls. And I'm going to tell you why I call it that. Because what you're doing is trying to figure out, looking at a graph, what are my limits to the left-hand side and the right-hand side of my graph? What does it go to? Because remember, when we're talking about these are our x values. So when we're looking at a domain of a graph, we're trying to figure out what are the x values that we have? What is the set of numbers that sort of contains my graph? And so what I do is I draw walls on each side of the graph to see where it's at. In the case of a lot of what we're going to be seeing both today and on your homework, you're going to have graphs that stop. They don't have little arrows that go in and go to a different direction, because we're going to be looking at something where we can say, okay, this goes from here to here. And so when I look at this, what I tend to do is say, all right, my left-hand side, I don't have any values here at all until I get right there. So my first graph point is going right through here at x is equal to -3. Now, do you guys see where I can find that x equals -3 part? Because that's generally where we have issues. It's not that we can draw the line, it's that we understand where that number comes from. Do you guys see where that comes from? With no response, I'm going to point to show you where that comes from, and then you tell me if it makes sense. If you look, this is my 0, 0, right? All I care about with domain are the x's. So I'm just looking at where that value is on the x-axis. If I look at where that value crosses here, it's -1, -2, -3. So this left-hand side wall is where x is equal to -3. If I look at that right-hand side, this is the place that if I drew that line here, it crosses right there. And this is at 1, 2, 3, 4, 5, 6, or x is equal to 6 in this case. So when we're talking about the domain of this graph, it says it's all of the x values between -3 and 6. So these two numbers are telling us our endpoints of the domain, and it's everything in between, because if you look, this doesn't stop. This always has values. It's just that I don't care how far up and down it goes. I just care about left to right when I'm talking about domain. Does that make kind of sense, or does this feel familiar to you? Have you seen something like this before? This is where you say, maybe. Okay, I think I got it, which is actually not too bad. I'm fine with that. Let me look for just a minute to see what we can do about our range then, because if we look at this, it's the same general idea. Now, I will tell you, this stuff doesn't print out in color, which is really too bad, because I made these notes. When I made them, I used different colors, which is kind of cool. So I'm trying to do that as well. So range is, when we're talking about this one, I talk about floor and ceiling. When we're talking about the range, we're talking about the top end and the bottom end. So where is the floor? Where is the place where it doesn't go below this value? Where is the ceiling where it doesn't go above this value? So when we look at this one, if I'm going to go across here, my floor is at the bottom part of this graph. How far down does it go? So I take that, go across to the left and to the right. If I count that, that's -5. So y equals -5 is the lowest value we have for anything. And if I look up here at the top, this is the highest value I have. So if I take that all the way across to see where it crosses, that crosses at y is equal to 4. We just count on the y-axis. Again, I don't care about how far we go left and right. I just need to see where's the top, where's the bottom. So all of the y values between -5 and 4 is what we're talking about. And normally when we're talking about domain and range with graphs, we're not talking about specific points. Like rosters would make no sense. We're just talking about how far does this go left and right? How far does this go up and down? Okay. Now, I want to take a minute to then look at one so we can do this one kind of together. All right. So right now, here is my new graph. Clearly, we're going up and down with a lot of stuff here. So we're going to find the domain and the range. Remember, domain is our left and our right. It's our walls. So what I do when I'm doing this, I'll use two different colors here. First thing I'm going to do is go to the left-hand side. And if I look here, I look and see that this point right there is the farthest left I can go. So I'm going to draw a wall on this side, going straight through here. And up at the top, I'm going to write the number of where it crosses through the x-axis. This is -5. This is left-hand side is x is equal to -5. Now, I'm going to grab a pen, see where my right-hand side is. This is the farthest right it could go. So this is the wall on this side. It's down to there. Goes up to the top here. And this is going to be at x is equal to, that's 5, 6, x equals 6. So right now, we have our two walls. There are no points on the outside of either of these. So our domain is contained within those. That means that what should I write then? In terms of how I write this for the domain values, how would I write that in words? What would my domain be? Anyone? This is where you say, Mr. Bechtel, it should be, and then you tell me. Somebody say something or write it in the chat so I can say if you're right.
Would it be like in the middle somewhere?
It would be all of the values actually in the middle.
Okay.
When you're looking at this, the first thing you should write for your domain is all, now hold on, is domain X or Y?
Isn't it the in-between?
That's right. If it's in the in-between, you tell me, is it X or Y values in between? We're talking domain, is it X or is it Y?
X.
You're both right. Rima and Sylvia are both right. All X values between what two numbers?
-5 and +6.
Yep, -5 and positive 6. Now, this time I actually made the colors the same way that they were over there so we could see the left. All x values between negative 5 and 6 is what we're talking about. And so that's the place that we're thinking about this. When I'm doing the domain, or when I'm doing the range, I'm going to tell you right now, this is going to be all the y values between, and then we've got to write what it is between here. So this might take just a second. All the y values between. All right, so I'm going to do floor and ceiling here. From the floor, I come up from the bottom to see where my first part of the graph is. So if I'm coming up here, that point is the lowest point. So I'm going to draw lines all the way across to the left and to the right. So right here, this is y is equal to, now let's look. That's 0, -1, -2. So y equals -2, that is my floor. Now, if I'm going to do the ceiling, we got to come from the top here and see that this is the highest point that I have. So I'm going to draw this line all the way across and all the way across here. And this is at y is equal to, all right, 0, 5, 10, 11, 12. Y is equal to 12. So if I'm looking at this, this is all the y values between, and then you just have to say the range, or say the range between them. Between -2, so that's the bottom one, and the top value, which we just found out happened to be 12. And so what we're saying here when we tell us what our domain and our range is, we're basically saying what the limits of this graph are. Everything that I'm looking at for the graph of this function falls between these two x values and these two y values. So I'm essentially honing in on what it is that I'm looking at to see that there won't be any values outside of this. So I know that I need to focus my attention right there. Okay. Now, is there a ton of use for this? Not this second, but before the end of the unit, yes. We're going to be doing quite a few things to make sure that we can look at what domain values work and what doesn't and why. But this is sort of why I want us to start to identify it so we can start to get to those conversations. Now, I feel like I have a whole other side of this, but in fact, I don't. I just looked. This is the last page of things that we're going to be doing for our notes today. Tomorrow, what we're going to be talking about are different ways for us to represent this sort of thing when we talk about all the x values between -5 and 6, how do we write that? All the y values between -2 and 12, how do we write that? So really and truly, guys, we are done with information that we're going to need to use for today. So let me show you really quickly what homework assignment you are going to have as we look at something like this. Let's see if I can actually find it. Hang on. Boom. And I'm going to look at this. And we're looking at the slides homework. And it'll look like this. So when we look at that, here's what you're going to have. For our first page of this stuff, man, this is taking a while to load. So we're going to start off. And your first page of this is we've got this set of points. List the domain here. So basically, you're going to list your x values from these ordered pairs. The range here, you're going to list the y values. So all you got to do is just go here and start typing. So if I'm going to go here, I think it's right. Double click. Well, you got to go to the end of it. You do a return and just start typing the numbers. Just make sure you put commas and you should be good. Same thing for the range. Or for our next page, hey, look, we've got each of these. If I plug these values in, what values here are going to be the ones that I get out? And so you take whichever answer you think it is. Let's say this one, you drag it into the box. That's all you got to do. Now, I don't know if it's that one because I haven't done the work, but oop. And then Mr. Bechtel screws it up by moving the whole thing. So let's see if I can actually get it so that I'm looking at. Well, damn. Y'all, don't look at what I just did. This is wrong because I put this in the wrong place. But anyways, you get the general idea. This is what you're going to be doing. And I recorded myself saying damn. So let's say it again. Damn. All right. Here's what I'm going to do. I'm going to stop sharing. I'm going to say, guys, that's kind of it for me today. So I'm going to